Welcome to the lesson, Dr. Powell. Let's take a look at a proof of why a ring of integers is a ring. Okay, so let's let K be a field extension of Q, and let's let alpha and beta be algebraic integers, which means there exists polynomials f and g with coefficients in z um, is that such that alpha and beta respectively satisfy them. And we'll say this one's degree n and this is degree m. Okay, so now let's take a free z module generated by the products alpha I beta j as we go along from as I goes from 0 to n minus 1 and j goes from 0 to n minus 1. Now, if we multiply by alpha, that acts on this z basis, right? So if we multiply alpha times one of these, it increases the power of alpha for each of these. And if we get up to alpha to the n, we use this relation to replace what we have by, since this is monic, we can write alpha to the n in terms of the smaller powers of alpha. Thus, we can express on this basis multiplication by alpha as acting on this basis, and therefore get a matrix for multiplication by alpha on this free z module. Similarly, we can do that for beta times, so multiplying by beta, and we're using these relationships. So we get matrices for multiplication by alpha and multiplication by beta. Now, if we look at the characteristic polynomial of a plus b, we have that alpha plus beta, so multiplication by alpha plus beta is the same as multiplication by a plus b, and so a polynomial that a plus b satisfies will be one that alpha plus beta satisfies as well. And this characteristic polynomial is monic, therefore alpha plus beta is an algebraic integer. Similarly, alpha times beta is also a algebraic integer because it's a root of the characteristic polynomial of a times b, which is monic. Now, what if right here in this characterization, g didn't have coefficients in z, but had coefficients in z adjoined alpha, using this relation that f of alpha is equal to 0. Then if we did that, we could express beta to the n in terms of these smaller, or these basis elements right here are smaller powers of I and j in here, which means that we could still write beta as a matrix on M right here and still get this, and still realize that beta actually is an algebraic integer, even if we were to assume that the coefficients of g were simply not necessarily integers, but z joined the algebraic integer alpha. Thanks for watching.